So hello. Thanks for coming and thanks for having me here. My name is Warski. I come from Poland and I'm visiting here for a while. And I would like to talk about how to do dependency injection without any frameworks in Scala. So I have got a couple of slides and then we will do some live coding. And yeah, we'll see how it goes. So if you have any questions during the talk, please just ask them. Anything, just tell me. OK, so yeah, well, dependency injection, I guess it's quite a popular pattern, right? Most of us probably heard about it, used it in some form, either in Java or maybe in Scala. But especially in Java, like there's this whole thing called dependency injection containers and frameworks, and it may seem that dependency injection is in fact something complicated. And I would like to convince you that it's actually quite simple. So if you think about it, especially when we are using dependency injection through constructor parameters, that dependency injection is really just using parameters, right? It's nothing more. It's just a fancy name for passing values to a constructor or passing parameters to a constructor. So it's really very simple. And to use parameters, we don't really need any frameworks which do some magic for us. So maybe we can just use Scala instead. So one of the things, there's like a number of features in most dependency injection frameworks or containers. And one of the features is that you don't have to write new anywhere, right? So maybe we shouldn't be so afraid of writing new in some places of our code, but maybe we can avoid that as well. OK, so that's just like a very quick introduction. And now a very quick introduction about me. So yeah, I'm a software engineer. I'm a coder and the co-founder of Software Mill. Software Mill is, in my personal opinion, and of course, which is very objective, one of the best software houses from Poland. We do a lot of things in Java and Scala. We are a type-safe consulting partner. We have a flat company structure, so everybody is a CEO, and yeah, that's like, well, it's not that funny. Like you have a lot of responsibility, right? Yeah, and so personally, I've been doing some open source stuff for some time. I've written a Hibernate module called Inverse for entity auditing. MacWire, which I'm going to talk about today, ElasticMQ. I write a blog sometimes, hopefully about interesting stuff, so I invite you to visit. And I have a Twitter account, which probably isn't that weird. OK, so let's start coding. So first of all, I'll create a new class. Let's call it SF. Not a very original name. So it will be an application. So first of all, I like to see an examples. We will need an example object graph, right? So whenever we do dependency injection, we need some form of an object graph so that we can actually, express the dependencies between the various parts of the business logic, and so that then we can satisfy the dependencies using our library container or something like that. So I'm going to, our example will be food-based. So we will want to create an instance of a restaurant so that we can eat a steak with potatoes. So, yeah.
Are you going to post the code?
Yes, the code will be on GitHub. Yeah, it is on GitHub actually. OK, so we will have a number of classes. So first we will have a field class. We will have a digger class. So on the fields we'll grow potatoes, and the digger is used to dig out the potatoes. Then we will have a potato farm, which has two dependencies, a field and a digger. So that's the agricultural part. Then we have a cow pasture and a meatery, where we transform cows into meat. And finally, we have a restaurant. Restaurant takes potatoes takes meter, takes the meat, and it has a single method, order steak with potatoes. And we will just show the instance. Welcome to this. Here's your order. Okay, so like typically, I have written all the classes here in in one place, but typically we would have like a number of packages, right? Would like have probably these three would go into one package, right? And that would be another package. So our logic would be divided somehow, but just so that you can see the example on one page, it's all written here, right? But normally we have our business logic divided into a number of packages, a number of classes, and so on. Right? So another thing I'm going to do just for demonstrational purposes is I'm going to make these case classes so that we can see that we get like nice two-string representations automatically without actually writing any code. But that's only for the demo. Okay? Okay. So now, we have these objects, right? They have some dependencies, and so like the dependencies from a graph, right? So we have an object graph. So we want to create that object graph somehow. And so our goal, of course, is to call the order steak method on the restaurant. So in order to do that, we need to have an instance of a restaurant, right, with all the dependencies. So like the simplest thing that we can do, and that works in a surprisingly large number of situations, is we can simply create the new instances by hand. So that is going to be called manual dependency injection. Okay? So let's do that. Right, so we create a field. First, we create a digger. Okay, potato farm with a field and a digger, a cow, a meter. And it depends on the cow page, right? So we pass all the dependencies inside parameters. And finally, a restaurant depends on the potato farm and the meter, right? And now we can call our method and hopefully eat. So let's just see if the Scala compiler works and if this runs. Hopefully it does. So now when doing manual dependency injection, while all of the classes are like spread, right, somewhere in various packages in your application, this part where you actually create the object graph is going to be written somewhere like as far as possible, right, like at the end of the world. So you actually create the instances only when you absolutely have to. So like the main entry point of your application, you create the instances, you satisfy all of them by passing the parameters, and then you can run your application, right? So this part over here, that's like spread out, right? And this, typically when you do manual dependency injection, you just write it as late as possible, right? So you want to avoid creating the actual implementations and actual instances as long as possible. Yeah. So and we can see that it actually worked, right? I'm not sure why it's smaller one than the upper font, but yeah, you can see that the toString got generated nicely, and the object graph is generated nicely. Okay, so that's manual dependency injection, and as I said, if it works in a surprisingly large number of situations. We don't need any containers, right? We don't need any kind of reflection, annotations, and so on to actually do it. It's very easy to understand, which is also I think it's always good to have code that's easy to understand. There's no when you deploy like a jar using Spring or something like that, right? So what happens is Spring scans the jar, looks for classes with the annotations, uses reflection to determine what parameters each of these classes has, and so on. So that's pretty complicated. Here it's much easier, and it works even with large object graphs. Okay, so now a couple of improvements. So first of all, there's one thing that's not so good here. Let's say we change the order of creating a new instance of the potato farm and the digger. So what happens if we run the code now is we get a null here. So can you see that actually at the bottom? Can you see it at the end? Right? OK. So we get a null here. Now we get a null here because we have created the potato farm before digger was even declared, right? So at that point, that reference is null. OK? So now we can solve it using Scala quite easily. We just declare these as lazy vals. OK? And when these are lazy vals, Scala at runtime figures out the right initialization order. So we can now define our dependencies in any order, and we can use them in any order, and things will work fine. Okay? So that's just like a thing to remember when you are doing manual dependency injection. Declare your dependencies as lazy vals. Okay? So the second thing we can improve, we can simplify the new object creation a bit using MacWire. So let's add the MacWire extends the MacWire trait so now what we are going to do is we are going to replace the new invocations with the wire macro. Okay. So I'll tell you in a second how it works. Let me just do the replacing. Probably some smart regexp would do it for me, but I'm not going to write it now. OK. So now we have replaced all of our new invocations with the wire macro. So now we only we now only specify that we want to create a wired instance of some class. We can see if it still works. Hopefully it will. Yeah. So we get the same object created as before, right? OK. So what happens here? Wire is a macro. If you go to the definition, there's no sources for some reason, but yeah, it's a macro. It has, I don't know. You have to believe me, it's a macro. So what it does is it runs at compile time, and it generates the new instance creation code at compile time. So actually, if you would decompile this class as it is now, and what we have seen before with the news, it would be exactly the same, right? So the compiled version is the same. So like this will be at compile time. This will be replaced by new potato farm field digger. Okay. So what wire does is wire looks at compile time at the class. It has full access to the abstract syntax tree because it's a macro. So it looks at the class that's passed over here. It inspects the constructor. It looks what dependencies it has. And then it tries to find each dependency, right? So here the dependency, the first is field. So it tries to look up an instance of field in the enclosing scope. So the enclosing scope is the enclosing object and any inherited members. And the same happens for all the other dependencies. If there's more than one for a given type, there's an error. If there's none for a given type, there's an error. It's like it makes it a bit easier to do manual dependency injection because you don't have to actually write down the new invocations, right? You only say which class you want to wire. So if there's like 5 or 4 dependencies, it can get a bit tiring to actually write them down always. Another thing is when you add a dependency, you only have to add it in one place. So for example, if we would have potato-eating cows, so now the cow pasture depends on the potato farm. I guess it doesn't happen often that cows eat potatoes, but ours are special. So now we have only added the dependency here, right? And when we run it, the wire will automatically generate the correct constructor call without any need to update the wiring code. Okay? So we can see over here that our cow pasture now depends on the potato farm. So we can still do manual dependency injection. We can do dependency injection with wire. We can use, we can mix them as we prefer. Actually, when talking about mixing, another good side of manual dependency injection is that it's all Scala code, right? There's nothing special. So if you have some special object which needs to be created in some special way, you don't need to create like a provider or a factor or something like that. You can just write it, like new complicated, some complicated digger creator dot create, right? So you can do like you can write any Scala code to create your instance in there, right? It's just Scala. Okay. So, yes.
What happens if you have two instances of field?
Okay, so the question is, what will happen if I will have two instances of field? That will be a compile time error, because when trying to wire potato farm, the macro will not know which one to choose.
Will it work without lazy?
No, so the question is, will it work without lazy? Lazy doesn't have any impact. Lazy is just it's more of a runtime thing to actually initialize in the right order. But yes.
What if your potato farm constructor took in two fields?
So the question is, what if the constructor needs two fields? So then, right. So one, you can just do it manually, right, in the new invocation. Two, you can, they probably differ in some way. If it's exactly the same type, then you have to do it manually. But maybe you can wire field with grass or something like that, right? So we can add some like trait tags to actually differentiate them, stuff like that.
So could you elaborate more on what if I have instead of like concrete classes, today I have dependencies based on traits?
Right, so if it's like a field subclass here, so when we wire, we have to wire the concrete class, right? But then, of course, when we are looking up dependencies, for example, for the potato farm, right? So it will look for, it's like a subtype check. So it doesn't, so when here we are looking for a dependency of type field, right? It will find the field because it's a subclass of the field.
So when I'm wiring, I need to specify the specific class?
Yes, well, here you need to specify like the concrete implementation. But the dependencies can be on traits, of course. Yes. Yeah?
So in this example, I guess our meter will use the same code, the same potato farm. Right?
Exactly, so that's what I want to talk about now. So yes, so far, all of these dependencies are in fact singleton, right? There's only one instance created, like in the scope of this application is a singleton scope, right? So sometimes we may want to have more scopes. So we can do it using Scala as well. So let's say exactly that we want to create a new potato farm each time it's used. So it's a very simple thing. Actually, to see it first, I will just add a print line here. So it's like when the potato farm is created, new potato farm, and we are very happy about it, right? So when we run it now, yeah, we get one message, right? So now we can change it to a dependent scope. If you, I don't know CDI or Spring, dependent means that each user of the dependency gets a new copy. So instead of a lazy var, we simply do a def. And now we get 2, OK? So simply using Scala helps as well. OK, so now we are evolving our application. And so we have more classes, like we have 50 classes. And now our wiring code, which we have written like at the end of our application, has 50 lines or more. It's a big, ugly method. And we don't like it, of course, right? So we want to somehow divide things, split things. Actually, when did I start? Because I don't know how much time do I have left. I have time, OK. So we want to split our wiring code into modules. So let's introduce modules. So now we want to split our wiring code into pieces, so we will do it through modules. So we will have 3 modules, right? We can imagine that that's the first module, like the crop module or the crop package, right? That's the livestock package, and we have the restaurant package, right? So we have now we have 3 packages, and each package will come with a module which will define the wiring of objects in that package. Okay? So let's first define the modules. Crop module. And the livestock module. And the restaurant module. OK. So now we have 3 modules expressed as traits. OK. So we can actually put these modules next to the classes in the packages. And now we have to create the application. Crop module with restaurant module. OK. And yeah, so that's like these are some concepts that are the same as in the cake pattern. That's why I call it the thin cake pattern, because it's only part of it. So yeah, we like create our application by composing all the modules that we want, and then we invoke, right? We get the restaurant. So unfortunately, that won't work. Right? We get compile time errors from MacWire, and that's now even smaller. But what it says is that it cannot find a value of type potato farm at that line, right? So over here, we are trying to wire a cow pasture. However, in the scope of that trait, there's no potato farm, right? Because the potato farm lives in the crop module, and the livestock module has no idea about the crop module, OK? So we have to somehow express dependency between these 2 modules. So there are 2 ways to do it. The first way is to simply provide an abstract member, right? So we can simply write here potato farm that this module needs a potato farm, right? We have no idea what kind of potato farm. It can be any implementation. We just add an abstract member to the module, right? And now when we combine these 2 modules, these 2 are going to be combined as well, right? That's the implementation, and that's like the declaration of the dependency between the modules. Okay? So now the second the second way we can express dependencies is now the restaurant module, of course, needs to know about the meter and the potato farm as well, right? So we can here we can simply extend the trait with the crop module with livestock module, right? Now that's a bit ugly because it creates very stiff connections, right? We depend on specific implementations here, but it works as well. As we can see, we get our graph wired, right? So personally, I usually use this first style, right? So I like have a package. In the package, I have a number of classes with some business logic, and you know, for any pieces that come from other modules, I just add abstract dependencies over here. OK, so actually, I think I have. Didn't I start at 7? No, I did. OK, so I have to finish. That's good to know. OK, so I also have a play example. So maybe I'm just going to mention it, that you can do the same. You can integrate MacWire with play. So the main point here is that usually in play, when you create controllers, they have to be objects. So they are global, and I don't think that's too nice. So now there is a way to turn them into classes. And so, for example, here we have a controller which depends on the restaurant, right? It's the same restaurant as on the other example. So now we can have like fully testable controllers where we can provide mock implementations. So the only thing you need to do is in global, so you need to create a global object, which you probably have anyway if you have a play application. And there you have to override one method, getControllerInstance. And MacWire provides a utility macro with which you can generate like a lookup map for for your dependencies. Okay, so it's quite easy to integrate that with Play. So we can, it's you don't even you of course don't have to use the wire macro and so on. You can just do manual dependency injection and still have non-global controllers like proper classes and test them and so on. Okay, so yeah. Roots? Yeah, okay. Right, yeah, so it was like, so if you go to MacWire website, there's like step-by-step what you need to do. But you're right, you need to add an add before the controllers in your roots file, yes. Right. Okay, so just some closing slides. Now I have numbered them in a very smart way. And so which one goes first? Okay. So three things I want to mention. One is the cake pattern, which you can also use for dependency injection. I think actually in 2 weeks there's going to be a talk. Right, so I'm going to be back home then, so I won't be able to be here. Maybe that's better. But anyway, cake pattern, it has its good sides and its bad sides. The good sides is that it's pure Scala as well. It has some very natural way to use abstract types. And it also provides a nice way of declaring dependencies, a bit similar to what we did in modules. So it like takes the module idea a bit further. However, what I don't like about cake pattern is that it creates quite a lot of boilerplate. Like you have to surround each of your class with like a container trait, which you don't have to do here. And I think in the thin cake pattern approach, you keep the classes quite simple to understand, and you don't need the ceremony around. Okay, so yeah.
But do you think there's things that the cake pattern can do that the MacWire can't do?
So the question is there a thing that the cake pattern can do that MacWire can't? So one such thing is the abstract type members. Because in the cake pattern, in the component, you can have an abstract type. So here you could do it, you could simulate it with the type parameters, right? But there are some differences, like at least until dot is done, there will be still some differences. So there are some differences in how you can use that. Okay, so just to sum up MacWire, MacWire is, so like the main point is that I would like to convince you that dependency injection really doesn't, you don't have to use any kind of frameworks or containers. You can just start by writing everything by hand. And it usually works very well. There's a little bit of extra typing, but the gain in simplicity is much more valuable. You can also use MacWire to generate the new instance code for you. It is like, it's helping. You have also in MacWire, there's some helper objects to implement scopes like a session scope and a request scope. These are also quite simple things, like to implement a request scope, you just need like 20 lines of code or something like that. You can also do interceptors in a similar amount of code. And yeah, you can integrate with Play, for example. Okay, yeah, so I just told you about the scopes. Okay, so the project is open source on GitHub. It's Apache 2 licensed. The presentation is over here. Feel free to use it in any way you like. There's a bit more covered in the GitHub code than we covered here, but there's like 5 steps with which develop the application, so it should be quite easy to follow. And I have the stickers which I wrote about. So I have 2 stickers. One of them is an I'm proud of my code sticker, right? So who isn't? So the I'm proud of my code is a mod of our code review tool, which we use internally, and we try to see if other people are interested as well. So feel free to take these stickers. And the second is we have a weekly Scala newsletter where we, each week, there's a bunch of interesting, hopefully interesting Scala links Last week there was a comic, or 2 weeks ago, a Scala comic. So what can be better? Yeah, and I have stickers for that as well, right? These are quite nice, like these. So as well, if you'd like some, please take them. And yeah, and I have some vouchers for CodeBlock as well. They are like half-year licenses. So if you would like to take them, please do. And maybe there are any more questions. Yeah.
So do you know any companies or teams who are using this?
So I know one, there's Software Mill. But I know there's at least one large company that is using it, but they don't want to publicly admit it because it's their policy. Apart from that, I know there are users because sometimes I do get bug reports, which is, I guess, a good indication. But otherwise, I can't name any. Like. Thanks. Great to hear. Well, I hope it works for you. Yeah.
So why is this whole industry of defense injection? I've never used Spring. Right, it's gigantic. Why would people come up with something like that? Something monstrous.
Well, I'm not.
And Goose, right? So in Goose. So I mean, some people are fond of basically going through all these dances to revel their code in some stuff. I mean, what is and they're individually smart programmers. What is it about corporations which make them do this? And
That's a very good question, but I think it's more a psychological question and not a computer science question.
Technically, I mean, can you think of the reason why the company would not do this? I mean, where does manual dependency?
So it is a bit harder to do in Java because you can't do the modules that easily. Though I did manual dependency injection like small projects in Java, and it worked. Though like the methods to create the object graph, they were huge in the end, so that was not so nice. Apart from that, I don't know. I've been like a big CDI fan at a point and SIEM before that, but I was young, so hopefully that's
Perceived modularity. First of all, and second, the ability to move the mess out of the code to XML files makes the cleaner code, and cleaner code is good.
How about the XML files?
XML files, right? So it's fine. It's fine to move the mess, as long as it's good, but it's fine to come back.
Right, so I guess at a point everything got moved to XML, and now everything is in annotations, right? So annotations are like a programming language on their own, in a way. Yeah.
Earlier you showed one trait depending on another trait, you use extends. Can you use self-types instead?
Yeah, you could use self-types, sure.
The next question I had is how precise is the type search? Does it have to be exactly that type, or could it be a more derived type?
So the question is how precise has to be the type? No, so the check is a subtype check, simple. So it can be any subtype. Yeah. Yeah.
Do you have any support for, like, say, higher cardinalities or anything like that? Like, say, if you're looking for a list of, I'm comparing it to something like Spring, where you can define, say, multiple instances of a given service.
So the question is there any support for injecting a list of dependencies of a given type? No, there isn't. However, there is a bug or a feature request, however you call it. It would be quite easy to implement, but it's not yet done. But there are no like technical obstacles. Okay, I guess that's it. Thank you very much.